Hey, welcome back to my lathe. That's a piece of Delrin, and that's a lot of overhang for clamping it on 2 mm of depth. So I have 2 mm clamping height here and about 16 mm of overhang. Normally, with a normal 3-jaw or 6-jaw chuck without any precautions, I would say better don't do that. But these are gripper jaws. This is my soft jaw chuck, and I made a set of adapter jaws here with grippers. These bite into the material and deform it and create a form-fitting connection. And to rip this out of the chuck, that would take a lot of force. You would probably tip the lathe over. So let's see how I made these and how they work. The stock I'm using is Tulox 33, which is a pre-hardened and tempered tool steel, and it's pre-ground stock, so it's nice and parallel, squarish. Usually this stuff is not really very square, and it's usually oversized to give grind allowance. I'm not going to grind this, I'm going to mill it just faster. And I already have parallel in the vise, everything's clean. I usually, when I work with raw stock, I take a file and hit the flats of the stock with a file just to be sure to knock down every high spot, and then we put it in the vise, and this will square it up. The material is square in this direction, and the fixed jaw of the vise is vertical too. And when I clamp it now, the thickness will be standing up vertical, and when I mill the top here, I will get a 90-degree angle here. So that's a very fast way to square this stuff up. Running an 8mm 4-flute carbide end mill here. We're going for 3000 RPM. And Tulox 33 is considered, it can be machined. It's 33 Rockwell, which is a good amount harder or tougher than an annealed steel, or in normally annealed condition. 33 is still more than soft enough to even be machined with high-speed steel. Normal file will still take a very nice cut on it, but it's very tough. The heat treat is more for strength than hardness in this case. And yes, I have a face mill, of course. I have several face mills, in fact, but usually I don't like the face mill to be used on material that narrow, except if I'm in the mood to do a lot of deburring. You saw me running the end mill on the edge in this direction and in this direction. And that way I cut the burr into the material, and that leaves me minimal burr to remove later. If you run a face mill in one pass across the top surface, you pull a quite heavy burr on one side of the material that needs to be removed. And I will give you that a face mill is of course more impressive. But I don't need to impress somebody, I want to make parts. So now I'm checking my dimensions. Flip the part around, drop it onto the parallel with the machine side, clamp it down, and I give it a light tap. I'm just sure that it's seated down properly. Take notice what feeling what's going on is the clamping action very abrupt and with a very hard torque curve. Then you can be pretty sure that there is no dirt somewhere in your setup. If it feels like you're clamping against a spring, chances that something is wrong are very high. Okay, squared it up on all four sides. Hit my dimensions within caliper precision. Cutting the bandsaw pieces to length. I have one spare part over here in the vise to balance out the moving jaw, so we don't rock it too crazy. And the second part goes in here. I changed my end mills to a 10mm 3 flute because this has enough flute length to clean up the ends. The 8mm that I used before was barely long enough. I usually take a skim pass just to establish somewhat of a clean surface, and I take a measurement with calipers or micrometer, and in this case I need to remove 2.22 millimeters. So I zero out my DRO and then I step over 0.5 increments and just remove material. And yes, I did take climb and conventional milling passes. This is such light of a cut, 20mm height, 0.2, 0.5mm step over on a half decent tight setup mill, and a cutter that actually cuts and does not just push material around. That's no problem, even on a manual mill. And this thing has some backlash in the feed screw. So you have to try it yourself what you can get away with on a clamp milling pass. Okay, now as we squared up the blocks, I can machine this interlocking key structure into them, which mates up with the base jaws of my 3-jaw chuck. And you see a lot of numbers scribbled down here. These are my approach coordinates. I figured these out when I make the first one, so the next 3 can come out exactly the same. The important dimensions here is the width of the central key. This needs to be 12 millimeters, which according to my disc mic it is. And the width of this slot here needs to be 8mm plus 20 microns. And an 8mm gauge block barely goes in here. So that's good too. And once you figured out those coordinates, it's just milling by numbers. And for idiot proving, I put on some layout lines just to be sure we're doing the right thing here. 3 flute carbide end mill 2 fluter running at 3000 RPM, and I'm going to take the whole 3mm depth in one cut. Should not be a problem. And my numbers here say that for roughing I need to go to +8 and take a pass through. Now we go to -8. And that removed the majority of the material. Okay, I took 8.2, cleaning up the outside wall, 7.6 and 7.5 to bring this key in the center almost to size. And when we idiot check it with calipers now, we get 12.04, and that's our last step, moving over 20 micron from each side. That will bring us to 12 minus a little bit. This is basically a CNC program, just that I manually crank all the positions. Double check with the disc mic. Okay, that's 12 minus 10 micron. Pretty good. And now we rough out those two slots. I start at Y plus minus 1 millimeter to rough out a slot. Then I step over again to clean it up. And there we go. To double check what I'm actually doing, I mounted the jaws onto the 3-jaw chuck and mounted it on the lathe. And I'm checking the runout on the inside of the jaws before I bore the pockets for my gripper jaws. Runout with these kind of jaws is not very critical, especially as they bite into the material and deform it, but I want it to be reasonably accurate anyway. I might use these base jaws with their pocket for something else too. So I zeroed out here on top dead center on the inside of this jaw. The chuck is preloaded. I clamped on a bearing race down in there. This is +1, so let's zero this out. Okay, that's 0. Go to the next jaw. That's +1. That's +10 micron. And this one is +1. So the way that's pretty okay. The way I made my base jaws, for this chuck. These are modified hard jaws. The way I made these and the way I made my adapted jaws here, that matches up quite nicely within a solid 10 micron. I'm pretty sure I cannot flip those jaws around. I always kept my orientation the same when I machined them, because they are not exactly the same length. But that's pretty cool. Okay, finished all the major machining on the jaws. The remaining steps that need to be done on it are chamfering, deburring, some engraving needs to be done on the back side for the number of the jaw I'm using. The pockets are bored, and I used the wool hop, the boring head, to face the floor of the bore. So our gripper inserts, once bolted down, sit nice and sturdy in there. This is a go no-go gauge for 16H7. That's this side is 16.000 and this side is plus 18 micron, and that's used to check this fit. This is a 16H7 fit in my design. So the 16 millimeter end goes in nicely, and the 16.018 end does not. So that's a very good way to check your work, in addition to the three-point internal micrometer that I used. We're over at the lathe, and I have a stick of 123/63 tool steel in the lathe. And in the ANSI world, that's A2. It's an air hardening tool steel, and that's what we're going to use to make the grippers out of. Okay, roughed it down to 17 millimeter, final dimension is 16. I also turned a small step here which defines the gripper structure. Now we changed to our DCMT tool, and we're reducing the speed. Touch off on the end. Zero out our tool, move over 2.1 millimeter. Lock the carriage because we were creating a lot of sideways pressure by plunging with this tool. Now we change to a 9mm end mill. Holding the end mill in a collet holder for plunging is way more rigid than holding it in a drill chuck. I did a little bit of work off camera. I engraved the parts on the CNC router, and also I finally engraved the base jaws. They have a factory engraving in here, but you can't read this when the jaw is mounted. So put the same engraving here on the back. Rounded over all the edges and corners. Put a ball shape on the corners. And hit everything with a sanding sponge, just to clean it up. These A2 grippers out of A2 air hardening tool steel, I hardened them, and I'm not set up to do air hardening. It's quite a problem for me to do. I tried it with a stainless steel wrap, but I couldn't get the parts quick enough out so the air quenching works. So, and then I redid the hardening without the foil, and that means that my decarburized layer of steel is quite thick. So they have a soft shell and a very hard core now. Not ideal, but for a first test these should work. I will make a few more sets of these and just send them out for a proper heat treat. So let's put them together. They go in here. Screw goes in. And then they go on the base jaws. All within their number and in the right orientation. These jaws only protrude about 2 millimeters above the jaw, and this face of the gripper jaw is 0.2 millimeter behind the surface of the jaw. So the part should be pulled due to the angle of the gripper down onto the jaw. Let's see, and the jaw should bite into the material. So let's see, and well, they do. And not even with a terrible amount of torque. Here you can see the bite that the jaw took. And this could be really a good way to hold raw plastic stock with very little material on the back side, with very little waste stock in the lathe. So let's put this thing on the lathe and play a little bit with it. Okay, I have my torque wrench here, and I'm going to set it to, let's start at 10 Newton meters. That's 8 lbf ft, whatever that is. So part goes in, and I want to try it with the torque wrench first, so I can judge the torque needed to hold the part securely. It almost feels like 10 Newton meters is... Oh, there it is. There it clicked. And this dug in quite good. This really... Yeah, this is not... My only concern is that the material behind the gripper jaw could break away if I gave this a good whack in a crash situation. But for turning, yeah, this is a rock solid way to hold the stock on 2 millimeters of material. This I like this. This looks promising. And I have a ton of plastic turning in the future to do, making a lot of these couplers here. And this allows me to go with very little material, with very little extra stock, if I cut the material half decent square to make these parts. This is a trash piece, obviously, by the check marks here. But yeah, this looks very promising. I might experiment with the shape. Maybe I will do a half moon cutout on these lips, so I get 2 points that dig into the material and not this blade style. I have to look at commercial grippers. But we do not only want to do plastic, we also want to do aluminium. So I have a piece of aluminium here. Let's see if these work here too. Let's get our torque wrench in. There we go. Yeah, those take quite a nice bite into the aluminium too. Let's bring the camera in a little bit closer. Okay, that's a close-up view. And as you can see, this blade disc is gripping nicely into the material. And obviously this is not my first try. I tried it off camera already. And this takes a really good imprint into the material. And judging by the way the chuck tightened, I would not worry to machine on this. Quite aggressive. And if I was doing something that requires a ridiculous amount of holding force, I always can come in with basically an operation 0, hold the part not crazy tight because we're only plunging this little dovetail groove in here, just with a DCMT tool, plunge into the material, and then we have a form-fitting holding lip behind those grippers. And before this part flies out, this is what woodworkers do when they turn a bowl or something like that. They turn a dovetail contour and they have jaws that match it. That's basically the same. Or when you do CNC milling and you have a dovetail fixture to hold your part and you also prepare your stock with dovetail. And that's not going anywhere. I saw Peter Stanton use this technique on his large Mazak lathe, either to hold a smaller chuck in his large 4-jaw chuck, or even he prepared stock with a dovetail like that. Because it's basically a dual contact. You're contacting on the dovetail, on the angled surface, and either on this flat of the dovetail or on the backside, depending on the size of dovetail you machine. The dovetail, how do we create it? Here is a DCMT tool. There's the dovetail. Doesn't make much sense to put a dovetail on both sides of the part, of course. This is just for demonstration purposes. So this goes in here, line it up with the gripper jaws. Would be easier without a camera in the way. And I don't see any way how this could come out of the chuck, except for the material itself failing. Let's put on some safety glasses and give it a cut. Yeah, I'm not running, of course, not a crazy feed because I'm not mad. But still, this is like 6mm depth of cut with a relatively dull insert. It's a finishing insert for steel. Doesn't seem like the part wants to go flying anytime soon. So that seems to work. You probably wonder if this will work in steel too, and yes, it will. I already tried it here. It leaves way smaller marks on the steel, but steel being much stronger, harder than aluminum and plastic. A smaller engagement depth of the grippers will hold just fine. The only problem is the heat treat on my grippers is not brilliant. So they will most likely get damaged during this. But, well, they're around, and once a section of them is damaged, I can just turn them a little bit. So let's see, 10 Newton meters. There we go. Yeah, this is yeah, this is not going to be a problem. I like these already. Let's show these jaws in practical use. I have a chunk of Delrin that's cut a little bit oversized in length. And this goes in the chuck with the gripper jaws. I slightly tighten it with my hand with a normal wrench. Then I change to torque wrench set at 10 Newton meters. And I torque it down. There we go. And as you can see, I put a perfect square cut on the end of this piece. DCMT tool with a polished carbide insert for aluminium. I have the tool upside down so I don't get sprayed with chips. And I will close the chuck guard so I do, first of all, not get chips all over me, and secondly, if this lets go, I don't get hit by this in the head. And if you have a tool upside down, you need to run the machine in reverse, of course. So I'm turning the OD with a feed of 0.21 millimeters per rev. That's quite an aggressive feed, but that allows me to break the chip. Speed is about 1000 RPM. Okay, roughing is done. Now we change to a finer feed, 0.086 millimeters per rev. Now we go for an ISCAR DMDF insert drill combination tool that's also acting as a boring bore. Next tool is a radial grooving tool. Next tool is a chamfering tool. And the last tool is a G 1/4 inch by 19 tap. And these gripper jaws work marvelous. The holding power is really intense for relatively low torque on the pinion drive of the chuck. And yes, it deforms the material quite a significant amount, but it works. It just works. It's really a nice setup. I think I have beaten this topic to death. One last thing. Adam the Machinist on Instagram. Adam, you should follow him. He does some incredible work out of his garage. Way more sophisticated than the things I do. Had the idea that this could also be used to mount very simple soft jaws. Take the grippers out, machine a plug out of aluminium 16mm shank with a slightly larger head, bolt it in, and it's a very, very fast and very easy way to make a soft jaw. Maybe even only for one-time use, and then recut it for another job. I might try that, and I'm very, very sure that this will work. And also thanks to Robin Renzetti once again. He gave me the basic idea for this. He showed turning plastic with a large overhang with a clamping ledge on the back. I used that technique in the past quite a bit, but it's always the extra step of turning the clamping ledge, and with the grippers, just bites right into the material. Robin also showed a set of soft jaws with a gripper, with a turned gripper contour that bites into the material, but I wanted to try this, especially as I want to use these on a mill too. I think that's it for now, really. Thank you all for watching, and I'll be back.